I am going to walk you through 4 word problems. The first 2 word problems are simply just practicing writing an equation that represents the situation. You are more than welcome to go ahead and solve them for the variable, but in the instruction it's just writing. The last 2 examples we will write the equation and then solve for the variable. So our first example, Jackson had $15 yesterday. Today his parents gave him his allowance. Now Jackson has $20. Write an equation that represents the situation. So notice after the sentence, today his parents gave him his allowance, I have put an A in parentheses. This is my unknown, this is my variable, because I don't know how much money his parents gave him. We just know they gave him some money. Now the 2 values that we do have are $15, and it said that he had the $15 yesterday. And then the new number, or the second number we get, is that he now has $20. So after his parents gave him some amount of money, which we don't know, we give an A, he now had $20. So our equation needs to be equal to 20 because that's the total amount that he has now. So the question is, well, how did he get $20? Well, we know that he had $15, and now we got to determine what type of operation we want to use because he got some amount of money A and he now has 20. Let's read this again. Jackson had $15 yesterday. Today his parents gave him his allowance. He now has $20. Well, this sounds that he just added to the money that he already had. So 15 plus A is going to equal our 20. So this is what the equation should look like to represent this situation. 15 plus A is equal to 20. Now we can solve and determine how much money Jackson's parents gave him, but for this example, we just want to write the equation. So Jackson had $15 yesterday. Today his parents gave him an allowance. Now Jackson has 20. The equation is 15 plus A equals 20. All right. Our next example, Marion had $10 yesterday. Marion had $M yesterday before she went to the mall. She spent $30 at the mall, and now Marion only has 10. Write an equation that represents this situation. So the fact that she used to have this money, she had it, means that she probably has less money now than what she started with because she had some money. And then she went to the mall and she spent $30. And now she only has $10 left in her wallet. So let's think about this for a second. You have some cash in your wallet. You go to the mall. You spend some money. And now you look at the cash in your wallet again. You should have less cash because you spent some of that money. So she spent $30 of however much cash she had. Now notice that it says she had M dollars. We don't know how much money she had, but we know that she spent $30 of that. So, and now she only has $10 left. So we do want to have equals 10 because that's how much money she has left. Now we want to figure out what goes on the left-hand side of the equation. We have that she spent $30 from this amount that she had. So that means that she had an amount M and she spent some of it. She spent $30 of it, and that left her with $10. So our equation that represents this situation is M minus 30 equals 10. Again, we can use our steps for solving equations to determine how much Marion had before she went shopping, but for now we're going to stop here at writing the equation. All right, next, Lewis had $12 in his piggy bank. After he added the money, M, he earned for washing dishes, he had $14 in his piggy bank. Write and solve an equation that determines how much money Lewis earned washing dishes. So now we need to write an equation and then solve it for our variable. Our variable is M. And reading that sentence, it says he added the money. So we already know that we're going to have a plus sign because he added the money. We don't know how much money he added because it says added the money M. So after our plus sign, we should have our variable M. Now, if we keep on reading, it says that he earned, so after he added this money, he had $14. So that means he now has a total of 14, which means 14 is what goes on the right-hand side of our equation. So now we're missing this term right here, and it's this value. Lewis had $12. He had $12. He added some amount of money. We're not sure, so plus M, and now he has a total of 14. So now we have a one-step equation that we can use an inverse operation to solve. Right now we are adding 12, and the inverse of addition is subtraction. So I'm going to come and subtract 12 from both sides of my equation because what I do to one side I must do to the other. This causes the 12 to cancel out, and we're left with just the M on the left side. Oh, sorry. We're left with just the M on the left side. And then we have to say 14 minus 12, and that is 2. So M is equal to 2. He earned $2 for washing dishes. All right, our final example. Because Tony moved closer to the city, his train ride is now 30 minutes shorter than before he moved. Now Tony rides the train for just 15 minutes. Write and solve an equation to determine how long Tony rode the bus prior to moving. So now we want to first set up our equation that represents the situation before we can solve it. So let's look at our three terms that we have. We have that his train ride is now 30 minutes shorter, so we have 30. Than before he moved. And we don't know what that value is. Notice I put a variable there, B. And so that lets us know that we don't know how long his train ride was before he moved. So we're going to give it a variable B, before he moved. It says that Tony now rides the train for just 15 minutes. So our other value is 15. So we have 30. And I'm just going to underline this. We have 30. We have, we have 30. We have B. And we have 15. Okay? So again, when setting up our equation, we want to think, well, what is this total? What is this total amount equal to now? And it's 15. So on the right-hand side of our equal sign, we need how long he rides the bus for now, 15 minutes. So now we need to worry about the expression that goes on the left-hand side of this equal sign. And we're down with the 30 minutes shorter than before. So this term here, shorter, should tell us that he's riding the train less. And the word that we associate less with, or the operation we associate less with, is subtraction. So before he moved, he rode the bus for some amount of time, B. And now he's closer, so now his train ride is 30 minutes shorter. So we're subtracting 30 minutes from his original time before he moved. So we should have B minus 30 is equal to 15, because here's before he moved. We don't know what that was, but his train ride is 30 minutes shorter, so subtract 30, and he now rides the bus for a total of 15 minutes. Second thing we have to do is solve. So we have a one-step equation here. So if I notice I am subtracting 30, so I want to use my inverse of subtraction, which is addition. So I add 30, to both sides, because what I do to one side, I have to do to the other side. Well, that's going to cause the 30 to cancel out, and then we're left with just b on the left-hand side of the equation, and then we do our math over here, 15 plus 30, and that is equal to 45. So before he moved, his bus ride was 45 minutes.